Hi everyone, this is Mr. Cardoso again, and here we are in lesson 3 of the Introduction to Objects. In this lesson, we're going to talk about instance methods. So we have our fraction class here, which right now just has two fields, which define what the object is made of. We think of those as nouns, so it has a numerator field and a denominator field. And then we have our fraction calculator, which we had before, which created two instances of the fraction class f1 and f2. And as we have the images over here, you can see f1 and f2 on the right side of your screen. We've given f1 1 over 2 and f2 3 over 4, these two different fractions to represent in their fields as so. And f1 and f2 are considered to be instances of the fraction class. So they are f1 and f2 inside here. Inside this class, it has no idea what f1 and f2 are. It doesn't recognize those variables at all. They're not declared in here. But they're declared in this class, in the fraction calculator, as the secondary programmer using the fraction class. But what it does know is that f1 and f2 are a type fraction. And so in this class, it does recognize that. And so it assigns a numerator and denominator field to each one. Those are called instance fields, again, just to remind you, because they are individual for each instance of that class. So they're not shared. If you have 1,000 instances of fraction class, if you have 1,000 fraction objects, each one will have its own unique numerator and denominator field for representing whatever that fraction is. So now this fraction class is pretty useless. All it can do is give you those two fields and tell you what it is. So if instance fields are just what the object is made of, and I like to think of those as nouns, so this is what the object is, then what about what the object can do? And that's instance methods. Instance methods, I like to think of them as verbs, if you will, action. This is what the fraction object can do. Now, one of the things that's annoying here is when we want to print out as the secondary programmer in this main method using the fraction class, maybe making a fraction calculator or something like that. When I want to print this out, what happens? Do you remember? Well, if I try to print this out, we basically get the class name of the fraction object and then the unique identifier, which tells us, these two are two different fractions. Well, that's good, but it's kind of useless because I want to know, what the numerator and denominator is. So if I'm the secondary programmer, I'm going, okay, f1.new, this is a workaround, plus slash f1.den, something like that, and I can do the same thing here, .new plus slash plus f1.f2. You can see how annoying this is. So imagine that every time a secondary programmer wants to, what did I do wrong? Oh, I forgot plus sign. Wants to print out their fractions, they have to do that every single time. Well, rather than doing that, what we can do is, so now that works, but it's annoying to have to do that every single time. So what we can do is the primary programmer, the person making the fraction class, can add that as an instance method, give it something to do so that it's much easier to make that happen. And one of the things, so what we can do is add that as a method here so that it can be called by the secondary programmer instead of them having to do it each time. So we're going to write a method just like we did before. Now before we learned about static methods. We're not actually going to put the word static in there, so leave that word static out. And we're going to go public. The next thing would be the return type. So here we're going to return a string of what we want the object to look like. And then we are going to call this method something of our choice. So we're going to say, for example, print me out. So basically print out the current fraction that is calling it. Now, the reason why we don't need any parameters, we don't need to say, hey, take a fraction to do this, like fraction f1 or something like that, is because this is an instance method. Notice there's no word static in here. So how it's going to work is it's going to operate on any instance that calls it. And in fact, that's how it has to be called by the instance. We'll see that in a second. So here we're going to go return, because we have to return a string. Now I can't just write this. I can't write return f1.num plus f1.den, because in this class f1 has not been declared. It has no idea what f1 is. So if I try to compile this, it gives me an error. It says I don't know what f1 is. It's been declared here by some other programmer who decided to call it f1. This is just out of their own mind, their own variable name, has nothing to do with this class here except that it is a fraction object. So we don't put f1 in there. And what we can do is we can say, we can leave it blank, or we can write this.num and this.den. Now notice that the this is a keyword, and that's why it's turning up, just like return in public, it's turning up in this bright blue color. It's a keyword, and you don't have to have this, you can leave it out, but basically what that's doing is it's making the implicit explicit. So let's just see how this works first of all, and then we'll come back and explain it further. So now instead of doing this, right, I don't have to do that anymore. Let's see how we call it. We would call it with f1.print me out. And here we'll go f2.print me out. Open close bracket. Now, let's take a look at this a little bit deeper. f1 is an instance, as we said, it's an instance of the fraction class, so is f2. So I said because we left out the keyword static, we have to call this method with an instance of the class. So an instance of the class, fraction, is f1. So f1.print me out. Now, print me out is the name of the method, and there's no parameters in the brackets, so no parameters in our brackets. f2.print me out. So over here, just keep in mind on the right-hand side of the screen, we've got f1 and f2 with its current values. So when f1 calls print me out, then f1 becomes the this. This is a fraction, the current fraction that it's talking about. So now f1 gets transferred into the this. So basically this is like f1.num, which is 1, and this is f1.den, this .den over here. And so it returns 1/2 to this, and it returns it as a string, and this gets replaced with that string. Now when f2 calls it, it jumps back out, f2 comes in here, and f2 will become the this, right? This.num and this.den. So then it would use 3 and 4 for this.num and this.den respectively. So if I compile that, that runs beautifully there. So that's exactly what's happening. So now every time, as the secondary programmer, I'm using this fraction class, every time I want to print it out, I just have to use this method rather than typing that all out. Now, as way more convenient as that is, I can make this even more convenient. How? Well, we saw before that if I don't type the .print me out, what does it print? So let's try that. Hopefully you remember. It prints the unique identifier with the name of the class. So there's actually a method that Java automatically writes for you. There's an instance method that exists before you write any instance methods that's called public string toString. So let me change the name of this print me out to this special name that Java had already written. And by rewriting it exactly the same way Java has, so it has to be public string toString, and again nothing in the brackets, and with the S capital. So this has to be exactly the same as that in order to override the one that Java automatically wrote for you. So now I'm going to go back here and remember what this printed out last time. So I'm going to compile that. And oh yeah, this one doesn't exist anymore. So I can still call this one toString like this. So I changed the name. I can call it like that as well. Or I can leave it off. Let's see what happens. So now it works even if you don't put the .toString. As long as it's in a system.out.println line, what it's going to do is it's going to say from the context you're trying to print out this object. This object is of type fraction. Let's see if that fraction class has a toString method. If this toString method does not exist for that fraction class, then Java will use its own, which will print the unique identifier. But because we overrode that toString method exactly as follows, so you can write this toString method for any object that you create. Because we overrode it, then it's going to use the one that we have customly made to override their one. So here we don't even have to call it that way, although it still works, as you can see down here. We don't have to call it that way. We can actually go just F2, and now that's way more convenient because we've added some functionality for our fraction to be able to print out. So now as we go on, we're going to add more and more things to this fraction class to make it more and more useful. So another instance method, let's get to another example. Let's say we wanted to multiply two fractions. That's the easiest thing we can do right now. To multiply two fractions, hopefully you recall, I'm just going to write it over here. So we can, so if we wanted to multiply 1 over 2 times 3 over 4, we just multiply the numerator by the numerator. So 1 times 3 and 2 times 4, and so we get 3 over 8. So hopefully you remember that's how you multiply. So we can write that as another instance method. So again, public. Now what are we planning to return? What is the answer to this? When we multiply one fraction by another fraction, what's the answer type? So we get 3 over 8. Is this an integer? No. Is it a string? No. It's a fraction. The answer is another fraction. When we multiply two fractions, the answer is a fraction. So that's our return type. That's what we're going to send back. So we're going to say public fraction, and then we can say, let's call it times. Has a nice ring to it. Now, what do we need to be able to multiply? We need two fractions, right? We need one fraction times another fraction. So we need to be taking two fractions. So yes, we can do fraction, let's say F1 and fraction F2. We can do it that way, but I'm going to do it this way, where I just take one other fraction. Because keep in mind, when we call instance methods, we have to call it with an instance of the class. So we already have one of the numerators and denominators like this in the num and den field. So I can go, let's make a new fraction first of all. Fraction result, or let's call it product, because we're multiplying, equals a new fraction. Okay, and then I can go product dot new gets, right? And what am I multiplying? This dot new times other dot new. So I'm multiplying the two numerators. Now, this one is the key one. It's the key word, right? So it's the current fraction that's calling it, and other is just our variable name, because it makes sense, this and the other. And the same thing for product dot den equals this dot den times other dot den. And now we've assigned those into the product. And so here we can just go return product. And that is our instance method. So how does this work? So I go into the fraction class. If I wanted to multiply two fractions, I can go F1 dot times, and in brackets put f2.